In this example, they want us to simplify our equations, so basically combine our like terms and use exponent laws whenever possible. In part A, 4x to the fifth times 2x cubed, I'm going to take the like terms, or the digits, and start with that. 4 times 2 is 8. Now, as far as the powers go, I've got the same variable, so I've got x to the fifth times x cubed. Well, the power law says that I can write the base once and just add the exponents, so 5 plus 3, making my final answer 8x to the 8th. Part B is very similar, but written in a different way. They've used brackets around my terms instead of a multiplication sign. I'm still going to do the same thing. I'll take the negative 7, so the negative sign plus the digit behind it, multiplied by any other digits I see. In this case, it's a 6, so negative 42. And then as far as my a's go, I've got an a to the 8th multiplied by a to the 12th. So again, I'll use my power law that says write your base once and add your exponents. So negative 42a to the 20th. Part C is a division question. It looks a little bit different, but we're going to follow the same rules. So let's start with my digits, 20 over 5. In this case, 20 divided by 5 works out evenly to be 4. As far as my variables go, I have y to the 20th divided by y to the 5th. Well, your quotient law says that if you have powers with the same base, which we do here, base is y, we can just subtract the exponents. So 20 minus 5 is 15. Part D is a little bit tougher because even though it's a division question like Part C, 30 divided by 45 doesn't work out to an even number. So instead, 30 over 45 is a fraction I have to reduce. I can see that they both can be divided by 15, which would leave 2 here and 3 here. And that's as reduced as I can make that, so I've got 2/3. As for the powers, I've got b to the 14th divided by b to the 10th. So again, use your quotient law, write your base one time, and subtract your exponents, 14 minus 10, to get 4. So my final answer there is 2/3 b to the 4th power. Part E is very similar to A and B, there's just another term. Follow the same steps. Look for any coefficients first that we can multiply. I see the 3 and the 6, so I can either skip the middle term or realize that if there's no term there to see, then the number is actually 1. So whether you think of it as a 1 being there or you don't think of it at all, you'll still get the right answer of 18. And then look at all of your powers. I've got a to the 4th, a to the 5th, and a cubed. Power law says the same thing. As long as you're multiplying powers with the same base, you write the base once and add up all of the exponents. So in this case, 4 plus 5 plus 3. So I'm at 9, 10, 11, 12. 18a to the 12th. And finally, the last one is a division question. Like C and D, it's just written in a different way. Always take the number with the negative sign in front of it, negative 16, divided by negative 2, which gives me positive 8. So take the negative signs with it. And then I'm just going to write here what I have, n to the 5th divided by n. Remember, if no exponent is showing, the one they mean is 1. So it's actually n to the 5th divided by n to the 1. Sometimes it's important to write that 1 there so you remember to actually subtract it. This should be n to the 5 minus 1, or n to the 4th power.